All right, folks, today we are going to talk about current, voltage, and resistance. Just a reminder, I would like you to go ahead and have the student paced Nearpod up for current, voltage, and resistance. You can find that on Schoology under Notes and Nearpods. So make sure you have that up so that you can follow along. All right, a couple of quick announcements. Keep bringing in 2-liter bottles, and you will need a Snaptricity kit for this lecture. Feel free to share with your elbow buddy. All right, here we go. I want you to go ahead and take Quick Quiz B.2 and then go ahead and set up your notes. You can scroll down through here to see what the note setup looks like. But our essential question for today is, what is the relationship between voltage, current, and resistance? And the guiding questions are, what is current? What is resistance and what is voltage? Go ahead and pause the video, get the quick quiz and your notes set up, and then resume the video as soon as that is the case. All right, our learning target for today is I can use Ohm's law to show how voltage, current, and resistance are related. We're going to start off by looking at this simulation. I want you to go ahead and mess around with this a little bit. So go ahead and pause the video and mess around and see what you notice. All right, so what you can do here is you can change the amount of voltage and the amount of resistance in a circuit. And this causes a couple of things to happen. You will see that we have voltage represented by V, we have resistance represented by R, and this I right here is actually current. We're going to talk about that a little more in depth tomorrow, but for now, those are what those three things represent. So, as we change the voltage, what you notice is that the number of batteries changes. So, in this case, as we have more batteries, the voltage gets bigger, which is what we expect over here. And if you add all these together, 1.5 times 6, you would get 9, which is the amount of voltage we have. Let's go back down to about 4.5, 3 batteries. The next thing you can do is you can change the resistance. As you change the resistance, you see the R gets bigger and the I gets smaller. As you go smaller with the R, the I gets bigger. And those arrows, those orange arrows right here, represent the current. Now, you'll see in here, this is what's called a resistor. And as we increase the resistance, there's more little black dots that pop up. And those black dots represent kind of blocking of electrons. So you can kind of mess with that and see how does resistance affect voltage and current, and so on and so forth. All right. So, first thing we're going to talk about is current. And we talked a few days ago about electric charge, and that's just the amount of electrons that there are in a system. Now, current is when those electrons are moving, or the flow of electric charge, and we measure that in a unit called amps or amperes, which we use A to represent. Now, electric charge that moves between two places, such as terminals of a battery, is current. So you can see here, when we have a closed circuit, then a light lights up, you can actually see from these yellow arrows that electrons are moving, aka that there is current flowing. Now, I want you to go ahead and, with your Snaptricity kit, go ahead and build a simple closed circuit with the following things. A light right here, and an ammeter, which is this piece right here, set to 1A. When I say set to 1A, I want you to look right here. There's a little switch in the bottom middle, and you have 3 settings. I want you to set it all the way to the right. And just so you know, this does have to be set up almost exactly like this, otherwise it may not work. So, when you have it set all the way to the right, what that means is this bottom little arc right here, you see that where my arrow is pointing, or my mouse is pointing, that is the current. And where the orange needle is pointing is the number of amps that we have. So in this case, it looks like we have somewhere between around 0.3 amps of current. Yours might be different depending on the strength of your batteries. So go ahead and build that circuit, please. Now, I want you to go ahead and try to change the resistance in that circuit that you built. So the hint for this is try to make the light dimmer or the current, that orange needle, go down. You can change the circuit in any way that you want to using whatever pieces you want. So go ahead and pause the video and try to make that happen. All right, so resistance is the difficulty of passing an electric current through a material. And this depends on a material's thickness, length, and temperature. So in our circuit that you made, there's two ways, pretty common ways that you could, or three ways, I guess, that you could change it. One thing you could do is you could replace one of the wires with another light, and that would increase the resistance and cause the light, both lights, to be dimmer. You could replace one of the wires with the electric motor. That too would cause the light to become dimmer. You could also take the piece labeled M3, which is that copper coil, and put that between in the circuit, and that would also increase the resistance. That one in particular, because that's such a long piece of wire that we're really increasing the length, and that would cause the resistance to go up. So that is three different ways that you could have changed the resistance. Now, when you decrease the resistance, electricity is more able to flow, aka there's going to be higher current, and that's why the light is brighter. There's more current flowing through. So if you think about this, if you have ever seen warnings about electricity and water, water conducts electricity, especially when it's on your body. So when you have your body completely dry, your body's resistance is 100,000 ohms. So if you touch an electrical source, you might get shocked, but it's not going to be terrible. However, if your body is wet and you touch an electrical source, your body's resistance is much lower, which means that the current can be much higher passing through your body, and that's when you get electrocuted. The metric unit that we use to measure current is called an ohm, and it's represented by the Greek letter omega. So, I'm going to have you watch a video on the next slide for an in-depth explanation of voltage. Voltage is a little bit tricky to conceptualize and explain without me being in front of you for lecturing. So I found this video. It is a little bit long, but I want you to watch the entire thing. It does an excellent job helping you not only explaining what voltage is, but also helping you understand what voltage does. So I want you to go ahead and go to the next slide right here. Pause this video and play the video on this slide so that you can get an understanding of voltage. When you're done with it, continue this lecture. All right, so now that we understand voltage, we're going to actually use voltage in our circuit. So I want you to go ahead and build a parallel circuit with a voltmeter and a light. I have the diagram right over here how to do that. And one thing that you will notice when you're building it is because you are using kind of different levels of wires, underneath the batteries here, I have those little wires that are labeled 1, the little circles, and that just kind of elevates the wires so that they can easily connect. So go ahead and build this on that little switch over here. Switch it over to 5V. That's all the way to the left. And when you do that, we are now reading the top right here where my mouse is pointing. This top scale will tell us how many volts are flowing through our circuit. So your voltage should probably be somewhere between 4 and 4.5, maybe a little bit lower depending on the strength of your batteries. So go ahead and build this and then, or pause this video, build your circuit, and then come back and move on. All right, so this one's a little trickier. I want you to try to change the voltage of your circuit. And I want you to think about the demonstration that we did earlier and think about what is the source of the voltage from that demonstration when we were doing those sliders, and think about how you can change the voltage. So go ahead and take 30 seconds or a minute and see if you can figure out how to change that voltage, and then come back to this video and we'll talk about how to do that. All right, so the best way to change your voltage is going to be removing a battery and then taking one of your jumper cables here and connecting it to the 2 terminals of the battery. This is a little awkward because I was taking this photo by myself. so I didn't have two hands. But basically, I'm just pushing the wires against the two terminals of the battery port without a battery in there. So go ahead and try that, and what you'll notice is your voltage is going to read lower. It's going to read 3. That's because each battery provides 1.5 volts, and if you remove one battery, it goes from 4.5 down to 3. And so you'll see that changes, or that's how you can change the voltage of your circuit. So voltage is the push that moves electrons in a circuit. And this is caused by a difference in electric potential. These are the positive and negative terminals on a battery. And we'll get more into this when we meet together as a group next week. Now, the metric unit for voltage is volts, which we abbreviate by using V. All right, we're going to bring this all back now, and I want you to explore the PhET simulation from earlier. And I want you to, as you explore it, look at the numbers involved and see what you notice. So I'm going to go to the next screen now. Go ahead and pause the video and explore and see what you notice. All right, so one of the things that I hope that you see is that as we change the voltage, the current changes in a specific way, both down and up. And as we change the resistance, the current changes as well. And so what is that relationship? And we're going to talk about that tomorrow. All right, I want you to go ahead and take this 4-question quiz and see how well you understand voltage, or current, voltage, and resistance. And I believe that it should give you your answers at the end. All right, I want you to now, if you have any questions, go ahead about current, resistance, and voltage. Go ahead and type them here, and I will make sure that I answer any questions that come up when we meet together next week. Go ahead, please, and take a poll telling me how well you understand current, voltage, and resistance. Now, based on your answers from that poll, I want you to choose what you're going to do with the rest of your time. If you're a 1 or a 2, I want you to watch the video tutorial on Schoology about current, voltage, and resistance. If you are a 3 or 4, I want you to do Snaptricity projects 11 through 14 in your activity book. Like, actually do them. Read the stuff that's written down. Don't just build it, but actually read it. It'll help you understand it, I promise. If you are a 5, I would like you to record a video using snap circuits to explain current, voltage, and/or resistance to someone who is very confused. When you have that video done, you can go ahead and upload that to YouTube and send me a link, and I will post that on Schoology for everybody to see. Thank you so much.